All right, folks, here we go. Section 1.1, analyzing categorical data. So I want to highlight the fact that in this section we are only talking about categorical data. We'll save quantitative data for another section. As typically the case, we're going to start off with some definitions. I'm going to let you read these on your own. You don't need me to serenade you with reading definitions, but I'll just highlight a couple things. For frequency table, it is a table that displays the count, which is also known as frequency. So if we're counting something, whatever that count is also known as a frequency. A relative frequency table shows percents, also known as relative frequencies. So count and frequency mean the same thing. Percent and relative frequency mean the same thing. Moving on to pie chart. You've seen pie charts probably since the first or second grade. Of course, we'll find a way to make it slightly more difficult than what you saw back then. Pie chart is a chart that shows the distribution of a categorical variable. Again, that's because we're talking about categorical data in this section. And an important thing to note about pie charts is a pie chart must include all the categories that make up the whole. So we'll see examples where people try to make pie charts that where it's impossible because they're looking at categories that aren't part of the same whole. Last but not least, we have our friend the bar graph, also known as a bar chart. Graph used to display the distribution. Again, it's of a categorical variable. Okay, so let's jump into an example right away here. One of the things you'll notice in this lesson is we're going to be doing some graphs by hand. That's not typical. Usually we're going to be using technology to create graphs, but we are going to do a couple here by hand just to illustrate how we would do that. So we have an example here. What do teens post? Here are the percentages of 12 to 17-year-olds who post various types of personal information on their social media profiles, according to the Pew Internet Parent-Teen Privacy Survey in 2002. So let's first comment on this. This video is being made in the year of 2018, but the data here is from 2012. And anytime you talk about technology, 6 years is a huge chunk of time because things change drastically with technology year to year. So our textbook is a couple years old now. I think it was published in 2014, the textbook we're using. So it's currently 2018. Some of the data sets we might use are going to be a few years old, but doesn't change the fact that we can still analyze the data. Okay. First thing we're asked to do here is make a well-labeled bar graph to display the data and then describe what you see. Okay, so let's do that. All right, folks, there's our well-labeled bar graph to display the data in this distribution. Now, and again, as I mentioned before, kind of tedious to create these by hand, but we are going to do a couple just to make sure we are able to do that. Now let's kind of describe what we see. Well, when I take a look at this, just some simple observations, and here's what I notice. Okay, so some basic observations here. People in this 12 to 17-year-old age group are most likely to post a photo of themselves. That's the 91% category, nearly all of them, and least likely to post their cell number. And cell phone is spelled with an E. Okay, great. So now let's answer the question, would it be appropriate to make a pie chart for these data? Explain. And here's one where this can be tricky for some folks. The answer to this question is no. And here's the reason why. Okay, so again, we could not represent this distribution in a pie chart because each percent in the table refers to a different type of information. They're not parts of the same whole. So, posting a selfie is a different type of information than posting your school, than posting your city, than your email address, your cell phone. Those are all different categories. We could not create a pie chart of that because they're not part of the same whole. If I wanted to create a pie chart, I could create one for, let's just say, selfie takers. I could create a pie chart that would show 91% say yes and then 9% say no. And, if there were other categories, like maybe we could incorporate how often you post a selfie. Maybe we could say people who post one daily, weekly, monthly, annually, that type of thing. So that's the difference between a distribution like this, where all the different percents are not part of the same whole, versus one where we could create a pie chart. Okay, now let's move down, and I'd like to make a few comments about good and bad graphs. There's some things we should keep in mind when we do graph a distribution, and here are a couple of those things to note. Okay, so when we're creating a bar graph, our eyes react to the area of the bars. So let's make sure each bar has the same width. By doing that, the height of each bar will be proportional to that portion of the distribution. Okay, so that's one good thing we want to note about graphs is make sure that each bar has the same width. Here's another thing we should pay close attention to. Okay, so two-dimensional graphs are fine. What can sometimes happen is people want to get fancy and they're like, oh, I'm going to make my bars 3D. Well, 3D can be misleading, especially if you don't know what you're doing with perspective. Last but not least, with respect to making graphs, don't try to be cute and use pictures instead of bars. And again, this can be misleading. And we'll see an example of how that can be misleading in the next example. So, a misleading graph. In the 2008-2009 regular season, basketball player Dwayne Wade averaged 7.5 assists per game and 2.2 steals per game. So, if we take a look at the graph, we've got. Go ahead and note this here. Right about here looks to be the height of that. That's our 7.7. That's the height of that basketball. And then we've got the height of this guy at around 2.2 steals per game. So the height looks proportional to the quantity of assists and steals per game, but it is very misleading, this graph, because my goodness, the assist basketball looks huge. In fact, if we were to calculate the area of each of these, okay, so if we take that diameter of the basketball, 7.5, cut it in half, square that, and multiply by pi, we would have an area of approximately 44.2 units. That would be 44.2 units for the area of that circle. If we do the same thing for steals, so we take 2.2, the diameter, cut it in half, square it, multiply by pi, we have an area of about 3.8 square units. So very misleading picture, because the ratio of those two areas isn't even close to the ratio of the two measurements, 7.5 and 2.2. Okay, folks, final answer there. The use of circles make it look like D. Wade had more than 11 times as many assists as steals, when in fact he only had about 3.4 times as many assists as steals. So this graph could be better if equal width bars were used. Okay, folks, we're going to shut it down here and work on page 2 in a second video.